We specialize in innovation and creativity. These projects have enormous value. These are projects which people follow and study. That's all yesterday's stuff. I'm always looking forward to what's going to come and how we're going to challenge and how we're going to achieve. Well, we decided that we're going to have a look at the water speed record.
This is a key moment in the programme.
We're going to be running our education project, so the kids can actually follow it and understand how it works.
So much testing, so much research.
Well, you just really can't get any better, can you? It's a Richard Noble OBE, it's a world record attempt.
And it will get up onto its hydrofoils at about 80 to 90 miles an hour.
The combustion chamber and then the turbine.
In 2020, the Thrust WSH project was started to research the feasibility of engineering a watercraft that could achieve speeds of more than 400 miles per hour in a controlled and safe manner. Using state-of-the-art technology and innovative engineering, we're also aiming to inspire and educate a new generation of engineers.
The boat that we're putting forward is not actually a hydroplane. A hydroplane skids over the top of the water. This is a hydrofoil, and so we're actually trying to control the attitude of the boat at all stages. But we're using water to do it. We're using hydrodynamics to do it because this is a water speed record. Technology is a bit like mountain climbing, just to get to the top. But we want to develop the technology. And one of the big things, which I haven't mentioned before, is education. We want to entice the young generation, and we're talking about people at school. We want them excited. We want them to see it, get excited about it, and want themselves to go into it, because it's those children who will tell their parents and their teachers that this is what they want to do.
Computer simulations have played an important role in the development of Thrust WSH. At speed, the vehicle is lifted above the water on the hydrofoils, which remain just below the water surface. In order to characterize airflow behavior, an ongoing research program is underway. This involves running computational fluid dynamic simulations for a number of different operating conditions. In these images, blue path lines can be seen to advance towards the vehicle, which is travelling at a speed of 360 miles per hour with a ride height of 200 millimeters. These path lines are released 500 millimeters above the water surface, and they follow airflow currents beneath the hull. A turbulent flow structure can also be seen to extend behind the vehicle. The surface of the vehicle itself is coloured by the expected pressure distribution. Red regions show high pressures which coincide with stagnation regions. These are expected on forward-facing surfaces, and one objective is to minimise the size of these to minimise aerodynamic drag. Green and blue regions highlight areas of suction due to the locally accelerating flow. These areas contribute to aerodynamic lift, so it is important to understand how strong these suction levels are and what their impact is on overall vehicle behaviour.
The ugly boat is just a platform for us to practice and get used to and research the controls for the bigger boat. As far as the controls go, the ugly boat has got all of the main systems that the bigger boats will have. What that means is we have to have some way of working out what the orientation of the boat is in pitch and roll, and we have to have some means of measuring the ride height of the boat above the water, the foil depth. If the foil, for example, is deeper than we want it to be, then we tell that to pitch up just like an aeroplane wing would pitch up. That gives more upwards force, and it pushes that foil upwards, and it pushes that part of the boat upwards. If you want to encourage kids to get into it, just make them believe that they can do it. It's something that they can do. Anytime you can give them an aha moment, that's when you encourage them into science and engineering.
For me personally, it's been involved in such an interesting technological breakthrough on high-speed craft. I mean, it's something that I never thought I'd get involved with, but obviously Richard and a few others, we started this off initially, and we are all sort of interested in and trying to take something back for Britain. We've done a lot of CFD, computer-generated data on the thing. The universities have done that for us. We've collated it with a lot of boat testing, which I've been carrying out in Cornwall. We are progressing really well at the moment, and obviously the hydrofoils is our next part of the project.
This is a key moment in the programme. This craft will prove whether we've got a project or not, because we'll be running about 200 miles an hour, maybe more, using the hydrofoil system. This quarter-scale model is about 10 foot long. It's being built by the guys at 3DCM. They're doing an absolutely fantastic job.
There's a real synergy between what the Thrust WSH project, the potential it has in terms of education of young people, and what we're seeing the need in the composites industry for the education of young people and to inspire them into the composites industry, to really bridge that skills gap and get kids who are not in university yet. We want to look much younger. We want to inspire the next generation of engineers in this amazing industry that we have.
I guess it's similar to going back to previous project that used the same engine. It's all about drag and thrust. So compact military engine with an afterburner on it gives you the best thrust for the smallest drag.
We have the intake and the LP compressor. It's driven by the LP turbine. We then come to the bypass casing, and central to that is the HP compressor with the bypass on the outside of it. And then we come to the burners and the combustion chamber.
We've done 3 to 4 years of research on all this. Kinetic, of course, have been doing all the all-important hydrodynamic side of it. And all this is coming together. And we now know, in theory, that we're capable of doing it. Okay, but it's the practice which really counts. So now we're moving on to the next boat, which is this one, C3.2B. C3.2 is quite a beast, actually. It's got 350 pounds of thrust, jet thrust. It is a hydrofoil, so it climbs up onto its foils. It has got a capability of 225 miles an hour. Now, this is the proof of concept. And we're going to be running it June, July. If it all works out, we're then going to push on to the big one, C6. And that's what we've got to build next year and get on with it.
The current world water speed record of 317 miles per hour has stood for over 45 years. By combining cutting-edge technology, innovation and world-class engineering, Thrust WSH will inspire a new generation of engineers as we embark on a new adventure.